Good day, students. Welcome to mathgoodserve.com, where we don't just solve, we teach. In this clip, we're going to be going over problem 39 of the Algebra 2 Trick New York Regents exam for January 2016. Okay, I'm going to refer to this problem as the extreme law of sines problem. I'm giving it this title because in order to solve this problem, we're going to have to use the law of sines strategically multiple times in order to get the correct answers. Okay, so we have this composite figure right here, as you can see, that it's pretty complicated. This is information that we have. It says given that DC is 10, AG is 15, BE is 6, FE is 10. The measure of angle ABG is 40. Measure of angle GBD is 90 degrees. Measure of angle C is less than 90. BE is congruent to ED and GF is congruent to FB. Find the measure of angle A to the nearest 10th, and then find the side length BC to the nearest 10th. Okay, so one tip I would like to share with you concerning the law of sines is that in order for you to use the law of sines, you need to have one complete and one incomplete pair of angle side combinations in such a way that the angle and side combinations are opposite each other. Okay, all right, so in this case, we're dealing with a composite problem. So what we want to do is we want to attack the problem in parts. Now, the first thing we're to find is the measure of angle A. All right, angle A is in this triangle right here. So let's go over the steps for finding the measure of angle A. I just want to try and break it down as much as possible so that you can understand what's going on. If you get confused on any parts of this explanation, just ask a question in the comment section below and we'll be glad to clarify your concern for you, okay? All right, so these are the steps I'm going to use. In order to use the law of sines to find big A, what we're going to do is we're going to need big A and little a combination and the b's, little b and big B combination, okay? So let me go ahead and extract this triangle ABG to the side here, and then we'll focus our attention on that as I go over the explanation. Okay, so this is a copy of triangle ABG, okay? If that's big A, I'm going to call this little a. If this is big B, I'm going to call this little b. Okay, so as indicated earlier, I said you need to have a complete pair of side angle, one complete pair and one incomplete pair, okay? So we're looking for A, so big A and little a will be the incomplete pair, as you see in a moment, and then big B and little b will be the complete pair, all right? But in order for the A's to be an incomplete pair, I need to know what little a is, all right? So this is a question mark. So in order to find what little a is, I need side BG, which is equal to little a, okay? So in order for us to do that, I need to take a look at this triangle right here. From the information given, I know that BE, no, not that one, GF and FB are congruent. So this side, this segment right here, and this segment are congruent to each other. So if I extract this right triangle right here, and if I can determine what FB is, I'll double that to get A. And as soon as I get A, I can now use the law of sines to finish the problem off, okay? So let's go ahead and extract this right triangle here and use it to find what BF is. All right, so I have the triangle extracted to the side. This is big B, this is a 90-degree angle, this is E, and this is F. I know that the hypotenuse is 10, and one of the legs is 6, okay? So what do you use to find the missing side of a right triangle given two sides? You use the Pythagorean Theorem, okay? So let's go ahead and write that down. So this is A, this is B, and this is C. So the formula that I'm talking about, the Pythagorean Theorem, which I assume you're well acquainted with, is a squared plus b squared. The sum of the square of the legs equals the square of the hypotenuse, okay? So what I'm looking for is BF, which is little b in this problem. So let's go ahead and solve it. So little a is 6. So 6 squared plus little b squared equals 10 squared. So we have 36 plus b squared equals 100. Subtract 36 from both sides. Subtract 36, subtract 36. You have b squared equals 64. Group both sides. And b is going to be 8. Okay, so now that we know what little b is 8. We know what BF is. Okay, so BF is 8. This is 8. Now, since BF and FG are congruent, it follows that GF is also 8, right? So our little a is a combination of BF and FG. So if I can put a point right here, that's our F, somewhere right dead in the center. This is 8, and this is 8 because these two sides are congruent, right? So little a is going to be what? Little a is simply 8 plus 8, which is 16. Okay, so that's what little a is. All right, we're looking for big A in this problem. We know that little b is 15, and we know that this angle right here is 40 degrees. So we have one complete pair, the b's, and an incomplete pair, the a's. Okay, so let's write down the formula that we're going to use. Now, there are two variations of the law of sines. Okay, you can either have the angles on top or the sides on top. I normally allow what I'm looking for to determine what goes on top. In this problem, I want to find the angle A. So since I'm looking for the angle, I want the angles on top. So the formula basically is sine big A over little a equals sine big B over little b equals sine big C over little c. All right. In this problem, I don't know the C. I don't know the C's basically. Or in this case, is a G. So I have big G and little g. I don't know any of them. Okay. The complete pair I know are the A's, and the complete pair is the B's, and the incomplete pair is the A. All right. So I'm going to be using this first part right here. That's what I'm going to be using for this problem. Okay, so let's go ahead and use that. So to find that, I'm going to set it up. Just, you can use only two ratios at a time. So I'm going to go to find A. I have sine big A over little a equals sine big B over little b. Okay, when I carry out the substitution, I'm going to have sine of big A, the unknown, over little a, which is 16, equals sine of big B, 40 degrees, over little b, which is 15. Okay, now multiply both sides. In order to isolate sine A, I'll multiply both sides by 16. Okay, so multiply by 16 and 16. So I will have sine of A, because these 16s divide out, sine of A equals 16 sine 40 over 15. Okay, so we're going to plug that into our calculators. We have 16 sine 40 divided by 15. And our answer is 0.6856. 0.6856, so sine A is equal to 0.6856, I believe, 6856, okay? All right, so how do we get A isolated? We have to undo sine. How do you undo sine? You use the inverse sine or the arc sine, okay? So the inverse sine of sine A, or the arc sine of sine A, equals the inverse sine of this result when we computed this value right here, 0.6856. All right, so sine and inverse sines divide out. You're left with big A, which is equal to the inverse sine of our answer. So we have 43.2859. So 43.2859. The problem wants us to find the measure of angle A to to the nearest tenth, which is one decimal place. So the measure of angle A is 443 points. We're going to round up 3 to the nearest tenth. All right, that's just one part of this extreme law of science problem. Now let's go ahead and take a look at the second part. Okay, so for the second part, we're to do what? What are we supposed to do? We're to find side BC to the nearest tenth, okay? To the nearest tenth. Okay, so this one is kind of interesting. So this is the side we're looking for right here, okay? So in order to find big BC, side BC, which we could call little d, we need one complete pair and one incomplete pair, okay? But the deal here is that we're missing big B and we're missing big D. So we have just one side. We don't have a complete pair and an incomplete pair. Okay, so what we have to do is we have to find out what this angle is. So this D and this D will be our incomplete pair. And then we need to find out what this angle right here. Well, we want to use, it says, we want to find big B right here. So we can use the B's. Or you can also use the C's if you want to find angle C later. Okay, so all we need, however you want to configure your problem, you need one complete pair and one incomplete pair. The D's are going to be the incomplete ones. The B's or the C's will be the complete pair. Okay, so how do we find big D and how do we find big B? Now, let me show you how we're going to do this. Now, in order to find big D, this angle right here, we're going to have to use the triangle angle sum theorem on big B and big C because we can't use the law of sines yet because of the complications with complete pairs. So we need to carry out the triangle angle sum theorem on these three angles to find big D. In order for us to find big D, we need B and C both are missing. But check this out. Angle B right here, angle ABG and GBE form a linear pair. Actually, it's a linear triple. So we have three angles forming a straight line right there. So we can basically determine this angle by adding these two and subtracting from 180. So that gives us big B. Okay, so with big B, we have a complete pair. So we can now use the law of sines on big B and another incomplete pair. Okay, now C is what I need. But I know that from the given statement that BE, this segment right here, is congruent to this segment right here. So this entire side will be 6. So C's will be our incomplete pair, and B's will be our complete pair. We use the law of sines there to find C. Okay? Now after we find C, we use the triangle angle sum theorem to find big D. And then we have an incomplete pair, and then we can use either our C's or our B's along with the D's to find little d. Okay? So to get started, what I'm going to do is I'm going to dissect the problem. I want to pull out this triangle right here so I can label it and make it easy for you to follow. All right, so I've extracted that triangle. Let's go ahead and label it, and then we can get started. So this is big B, big C, and big D. Okay, so first step is we want to figure out the measure of big B. What is this angle's measure? So as indicated earlier, this entire thing is 180 right here. This red angle is 180 degrees. So let's write down a statement. the measure of angle AVG plus the measure of angle GBD plus the measure of angle B, well, let's just use CBD in this case, okay? CBD is the same thing as D, we'll switch later. If we add all these together, you get 180 degrees. Okay, so what did I just do? So what I'm saying is this one, this angle here, this one, plus this one right here, plus the last one, angle CBD right here, they all form a linear pair. They all add up to 180, right? So let's go ahead and input what I know. I know AVG is 40, so I have 40 degrees for that, plus the one in the middle is 90 degrees, right? Angle GBD, the one right in the center, is 90 degrees. And what's the last one? I don't know what that is, okay? That's going to be my angle B, so let me just put B here, equals 180 degrees. Okay, this angle B is this angle right here, and is equivalent to this. Let me color code it so you can see. So this one is going to be angle B. Okay, so what is angle B? We just basically solve this resulting algebraic equation. 40 plus 90 is 130, plus our angle B is 180. Subtract 130 from both sides, and then you end up with the measure of angle B, which is 50 degrees. Voila, we have one component taken care of, so that's 50 degrees. Okay, so let's go ahead and label away. So that's big B, this is little b, this is big C, this is little c. This is big D and this is little d. This is what I'm looking for. That's my final answer, okay? All right, so I know that little b is 10, that's given. I also know that point E is dead at the center of side little c or segment BD. Since BE is congruent to ED, this also is 6. So this measure right here is the 6, and this is 6. So if you combine them together, you get 12. Okay, let me put it somewhere else. Okay, so we have this, the top part, this is 6, this is 6, so that means the entire thing is double that, is 12. Okay, so that's what little c is. Little c is 12. So now we can use the law of sines to find big C because we have one complete pair, the B's, and one incomplete pair, the C's. So we can use the law of sines now, okay? So let's go ahead and do that. We're going to find big C so that we can find big D and then finish the problem off. So let's find big C. So we're going to use the law of sines formula. Since I'm looking for the big C, I'm going to use the variation with the angles on top. So I'm going to go sine big C over little c. There goes the incomplete pair. And then the next one has to be complete, sine big B over little b. Okay? Now let's substitute the knowns. Sine big C is unknown. Little c is 12. Equals sine big B is 50. Little b is what? What is little b? 10. Yeah. Okay, so to get sine C isolated, we multiply both sides by 12. So we have some cancellation action happening on the left side. And then we have sine big C equals 12 sine 50 over 10. Okay, so let's plug that into our calculator and see what sine C is equal to. Okay, let's plug that in. So we have, what do we have? 12 sine 50 divided by 10. Enter. So we have 0.9193. Okay, so sine C is 0.9193 to 4 decimal places. To get C isolated, we take the arc sine of both sides of the equation. arc sine of the left side and the arc or inverse sine of the right side also, 0.9193. Okay, so let's go back to our calculators and see what we get. So we're going to do the inverse sine of the answer that I got previously. And then I get 66.8172. So big C is 66.8172. Okay, so 8172. Looking good now. So let's go back to our triangle. Big C is 66.8. Now can we find big D so we can have an incomplete pair? Absolutely. We're going to use the triangle angle sum theorem to find big D. Okay, so let's go ahead and do that. Now want to find big D. To accomplish that, we know that let's see, big D plus big C plus big B is what? 180, the triangle angle sum theorem, right? So big D plus 66.8172 plus big B, which is what? What is big B? 50 is equal to 180. Okay, so big D basically is 180 minus the sum of these two. Let me add them up first, and then I can subtract their sum from 180. So we have this answer plus 50. Enter. So 116.8172, and I can subtract it from 180, right? So let me write it down first. 116.8172 equals 180, and then when I subtract that from both sides, that will give me the measure of angle D. Okay, so big D is equals, let's carry out the subtraction. All right, so let's do that with our calculators. 180 minus my previous answer, just to preserve accuracy. We have 63.1828. So let's write that down. Big D is 63.1828, I believe. Let me look at it again just to make sure. 63. Okay, good. All right, almost there. So now that we have big D, it's kind of like 63.18, and then it goes on and on. We now have an incomplete pair. So now we can solve for big D. Okay. So since I have my B's looking pretty, they're nice figures as opposed to this big C here is annoying. I'll just use the B's and the D's to finish this problem off. Okay. So let's go ahead and do it. So now we're going to use the law of sines to find little d, which is actually what we're looking for. Okay, little d is side BC. Okay, so since I'm looking for a side, I'm going to use the abbreviation of the law of sines where the sides are on top. Okay, so big D over sine, little d over sine of big D is equal to, I'm going to use the b's. You could use the c's if you want. Okay, it's the same thing. Little b over sine of big B. Okay, so little d over sine of big D is 63.1828 is equal to little b, which is 10, over sine of big B, which is 50. Okay, all that information I'm pulling from this triangle right here. See the b's and then the d's right there? Okay, so now let's proceed to get little d isolated. So how do you isolate little d? It's pretty straightforward. You multiply both sides of the equation by sine of 63.1828, and then this one by sine 63.1828. This cancels out, and then just plug that into your calculators, and then we get little d. What is little d? Let's see. We're going to get parenthesis 10 sine of our previous answer to preserve accuracy, divided by sine of 50, enter, and that's our answer, 11.65011. 11.65011. Okay, so side BC is equal to, we're asked to round it to the nearest tenth. Okay, so it's going to be 11.7 to the nearest tenth. Okay, so there goes the end of this intense law of signs problem. Thanks so much for taking the time to watch this presentation. I really appreciate it. If you found the contents of this tutorial beneficial to you, please give us a thumbs up. Your positive feedback is very valuable to us. Don't forget to subscribe for updates to the remainder of this review series and other great clips such as this. If you have any questions, just ask your questions in the comment section below and we'll be glad to provide you with support. More clips can be found on math.serve.com. Thanks again for watching and have a wonderful day.